Okay, so today we are going to still review our algebra skills a little bit more today. Today we're going to be writing and graphing equations of the line. So the first form that we're going to see is called slope-intercept form. So the slope-intercept form is y equals mx plus b, where the lowercase m represents the slope, the lowercase b represents the y-intercept. So in the first slide here, we have three examples, A, B, and C. So the first thing they want us to do is find the slope and the y-intercept of each equation, and then they want us to take the equation and graph it. Okay, so the first equation I'm going to actually work with in red, and on the second slide that I have here after this one, it's actually got a coordinate plane where I'm going to graph the three of these. But before I graph them, I'm going to go ahead and find the slope and the y-intercept for each one. So for the first one, example A, I need to get it into y equals mx plus b form so I can find the slope and the y-intercept. So in order to do that, my goal here is to isolate y. So I'm going to subtract 2x from both sides, and I get negative 3y equals negative 2x plus 6. Next, I'm going to divide all three pieces by negative 3. Now, notice the 2/3. It's a negative 2 over a negative 3. A negative divided by a negative makes this positive 2/3. And then positive 6 divided by negative 3 is negative 2. Okay, so now that I've got it into y equals mx plus b, I can see that my slope is 2/3 and my y-intercept is the negative 2. So my m for this one is going to be 2/3 and my y-intercept is the negative 2. Now, for example B, it's already set for me. So I can already see that my slope is the negative 1/4 and my y-intercept is the positive 2. So for B, and when I go to graph this, I'm going to do it in blue. So B, the slope is negative 1/4 and my y-intercept is going to be positive 2. Now, if you recall from the notes on Friday, whenever it's y equals a number, this is always a horizontal line. So the slope of my horizontal line is going to be m equals 0. My y-intercept, or my b, is the negative 3. So let's try to graph all of these. So let me go to the next slide. And the first one is A. And again, I'm going to do that in red. And it was y equals 2/3 x minus 2. All right. So again, your format is y equals mx plus b. This b that's back here is the beginning point. It's where you start. And we're going to start on the y-axis at negative 2. From that negative 2, I'm going to move my slope. Remember, slope is rise over run. So from that negative 2, I'm going to move up 2 spaces, 1, 2, and I'm going to run 3 spaces to the right. And my next point will be right there. I'm going to erase the jumps here. Now that I've come up with 2 points, I can connect them and make my graph. Now, if you want a more precise line, you can keep repeating the slope, the rise 2, run 3, and you can make as many points as you wish. Next, I'm going to graph B, which was already rearranged for me. So the negative 1/4 x plus 2. So again, here is my beginning point, positive 2 on the y-axis. Notice my slope is negative. So when my slope is negative, I'm going to go down and to the right. So down 1 and to the right 4. And then I can connect my points. And then the last one was the y equals -3. Again, horizontal line through -3. Has a slope of 0. So be able to graph these. Be able to find the slope, the y-intercept. Next, they're giving us the picture of a graph. They want us to write an equation in y equals mx plus b form, slope-intercept form, from the information we have in the graph. Now, when I write my equation in slope-intercept form, I need to fill in the slope, and I also need to fill in the y-intercept. Now, as far as the slope goes, I can do it two ways. I can either count the rise and the run boxes from the graph, or I could do the slope formula. So if I count my rise and run, so if I start right here and I count my rise, 1, 2, 3, 4, 5, 6, and then notice when I run to the left, this would give me a -3. So rise over run would give me a slope of -2. Now I can see where it's touching my y-axis, and that's touching it right here at the ordered pair 0, 4. So my b value is 4. And then just put in the y equals. And I just came up with my equation in slope-intercept form. Now, if you prefer to take the ordered pairs and then use the slope formula, the y2 minus y1 over x2 minus x1, you can also count or calculate the slope without counting rise and run. So again, if this is x1, and this is y1, x2, y2, -2 minus 4 over 3 minus 0 gives me -6 over 3, which also simplifies to -2. So I could have still gotten my slope by just using the ordered pairs without counting rise and run. Now for the next two slides, I'm going to introduce another formula, and it's called point slope. Now, I'm also going to show you how to come up with an equation of the line just using slope-intercept. So here is the form. This is another form. It's called point slope, and the formula is y minus y1 equals m, which is the slope, times x minus x1. So when we use the point slope form, we're going to be filling in the y1, the x1, and the slope. We'll be filling in those three pieces to write an equation in point slope. And I'm going to do that on the next slide. I'm also going to do it using slope-intercept to show you different options. So this question is asking us to write an equation of the line going through point -1, +1, and it wants that line to be parallel to this equation. Now, what do I know about parallel lines? What do they have in common? The slopes are the same. Good. So the slope of this line is going to be +2. The ordered pair the -1, +1 is going to be my ordered pair x1, y1. I'm now going to take these three pieces of information and I'm going to plug it into the point slope. Y minus y1 equals mx minus x1. So I'm going to replace the slope and put that number right here. Then I'm going to take out the x1, put it right here, and then the y1 and put it right here. So let's fill in. So y minus, and then my x1 is 1. My slope was 2. My x1 is -1. Now, I want to get this into slope-intercept form, so I need to distribute. But before I distribute, I'm going to go ahead and simplify this negative into a big plus sign. Everybody with me on that? I just turned this into a plus sign and then rewrote everything else. The next thing I need to do is distribute the 2. So it becomes 2x plus 2. Drop down the y minus 1. And now move the 1 over. So final answer, a line that is parallel to the other line that also includes the order pair -1, +1 would be the equation y equals 2x plus 3. Now, just to show you, in your Algebra 1 class, they might have not taught you point slope. They might have only ever focused on y equals mx plus b. So the other way you could tackle this problem is, again, we're still using the same slope, so the m equals 2, but this time the order pair, the -1, +1, is going to just be my xy in my slope-intercept form. So I would put 1 equals 2 times -1, and I'm solving for b. So 1 equals -2 plus b. Add the 2. 3 equals b. Now that I have the b, I go back, use this thing again, and now plug it all in. So y equals, the slope is 2, and the b I just calculated. Notice I got the same answer either way. So not sure which way your Algebra 1 teacher taught you. I really find the point slope kind of handy. Just be aware of it in case you're asked to write something in point slope form. So either method will get us an equation in slope-intercept form. Next, we're going to do a line perpendicular. So we're going to do the same process. The only thing that's different is when we pull the slope out of the equation, we're going to make it opposite reciprocal. So for example, here is my order pair. So the 2, 3 is x1, y1. I'm using point slope. The slope I need to pull out of this equation is opposite sign, so it'll be positive, and then reciprocal. So the slope for the perpendicular would be 1/2. So let's plug it in. Y minus y1, mx minus x1. Again, let's put the x1 in blue, the y1 in green, and then the slope is going to be plugged in here in red. So let's plug them in. So y minus 3 equals let me make this in green. So y minus 3, let's do this. And then the slope I'll do in red, which is going to be 1/2. Minus the blue, which is 2. So again, let's distribute. So y minus 3, 1/2 x minus 1. Add the 3. And now I have my equation of the line in slope-intercept form. That is perpendicular to this equation, including the order pair 2, 3. The next slide has another form of the equation, and it's called standard form. Standard form of a line is ax plus by equals c, and a and b are not both 0. A, b, and c are all going to be whole numbers, and a has to be positive. Now, they're not going to be fractions. They all have to be whole numbers. Now, for example, an example of standard form could be 2x plus 3y equals 4. That would be a standard form example. And we're going to see it on the next slide where they're going to ask us to graph it. And I'm going to show you 2 different techniques for graphing. Okay, so to graph this, I can do 2 different things. The first way I'm going to show you is what we did at the very beginning. I'm going to rearrange this into slope-intercept form. I'm going to solve for y. So I'm going to subtract the 3x from both sides and get 4y equals negative 3x plus 12, and then divide all 3 pieces by 4. So I get y equals negative 3/4 x plus 3. Now that it's in y equals mx plus b form, I can start at my beginning point, which is my y-intercept, and then from there move my slope, which is the rise over the run. Again, it's a negative slope. So my first point is going to go on positive 3. And then from there, because it's negative, I'm going to go down 3, 1, 2, 3, and run 4 to the right. And there's my next point. Again, let me erase my rise and my run count. Again, I can connect my points, and I have the graph of the line. Another easy way to graph something in standard form is to find the x and the y intercepts. So when we find intercepts, if you recall, this order pair of the y-intercept is going to be the order pair 0, 3. The y-intercept, the x-intercept is 4, 0. Notice they both have zeros in the order pair. So what we need to do to find the x-intercept, I set y equal to 0 and I solve. So 3x plus 4 times 0 equals 12. 4 times 0 is gone, so I'm just left with 3x equals 12 to solve. Divide by 3, and x equals 4. Notice it's the same order pair that I graphed already. To find the y-intercept, set x equal to 0. So 3 times 0 plus 4y equals 12. 4y equals 12. Divide by 4, and y equals 3. And again, I already graphed that. So if you were graphing using intercepts, you would put a point on 4, point on y equals 3, once you make those two dots, you connect them, and then that graphs your line. Now, when I teach this to my Algebra 1 class, I teach them a trick called cover up, where I cover up the x's and solve for y, and then cover up the y's and solve for x. So for example, if you have 3x plus 4y equals 12, and I want to find the x-intercept, I take y and I cover it up. And now what I'm going to solve is what isn't covered up, and then I get my x-intercept, which is the same thing I did by plugging in 0. Or take the original one, and let's say you want to get the y-intercept. So you cover up x. So if I cover up x, solve what remains, 4y equals 12, and y equals 3. Again, on the y-axis, put a point on 3. On the x-axis, put a point on 4, and connect them. So two different techniques for finding intercepts. That's another technique that you can use to graph something in standard form. The next one, next one. It's asking us to write an equation of the line for the graph at the right. So again, you can count your rise and run and just look for where it's hitting the y-axis. That's the fastest way. Or again, you could subtract the ordered pairs. So I already know it's going to have a y equals. I need to calculate the slope. So my rise is 1, 2. And my run is 1, 2, 3. So my slope would be 2 over 3x. And notice it's hitting the y-axis right here at -1. And that's your B. Now, if you don't like counting rise and run, then you would have subtracted the ordered pairs, put them into the slope formula, and calculate slope that way. And that's what we have to do on the next question. We need to calculate the slope first, and then I'm going to plug it into point slope. So this will be my x1, y1, x2, y2. So here I get 2 minus 5 over 1 minus -2. I get -3 over +3, which simplifies to -1. And that's my slope. I'm now going to use point slope, y minus y1, m times x minus x1. Again, I'm going to replace the y1, the m, and the x1. So y minus 5 equals -1, x minus -2. Change this to a plus sign. Distribute the -1. And then move the 5. So final answer, y is equal to -x plus 3. Again, I'm going to go through one by one, and we're trying to find an equation of the line. Now notice in the first example A, they're giving me an x-intercept and a y-intercept. Now if I were graphing these, I could put a point on the x-axis at 8, put a point on the y-axis at 2, and connect those points. However, I want to find an equation of the line. So I'm going to turn the x-intercept into an ordered pair. I can make it 8, 0, and then the y-intercept, make it 0, 2. Now what I'm going to do is plug those two ordered pairs into the slope formula. So y2 minus y1 divided by x2 minus x1. So I'm going to do 2 minus 0 over 0 minus 8. 2 over -8 gives me a slope of -1/4. I now can take and plug it in. Notice I already have the y-intercept, I have the b. So all I have to do is go back and plug in the m and the b, and I'm done. I didn't need to go through the whole point slope process because I already had the b. Now for examples B and C, these are just like the ones we did on the other slide. Again, we're going to practice. For the parallel, notice these two little lines here indicate that it's parallel. The upside down T on example C is the perpendicular. So for B, I'm using the order pair 6, 4. That's my x1, y1. The slope that I need for parallel is the same, so I'm using -2. Let's put it into point slope. So y minus 4, -2 times x minus 6, distribute, rewrite the left side, and now move the 4 over. So y equals -2x plus 16. Now, for the next question, really the only thing I need to do is take this and change the slope. Because the same information was given, I was given an order pair of 6, 4, and the slope was -2. However, I want perpendicular, so I'm going to modify my slope to opposite sign and reciprocal. So now for question C, I'm going to use this same thing right here, but instead right here I'm going to put +1/2. So y minus 4 times 1/2 x minus 6. Going to distribute. Half of -6 is -3. I'm going to add the 4. And y equals 1/2 x plus 1. For D, I'm given two order pairs. So again, I need to calculate the slope first. Again, I can label it as x1, y1, x2, y2. So let me do the slope formula. 1 minus -2 over 4 minus 3. 3 over 1 gives me a slope of 3. I now plug it into point slope. Y minus -2 equals 3 times x minus 3. Simplify this to a plus sign. Distribute the 3. And now move the 2. So the equation, 3x minus 11. The next one's super easy. They already gave me the slope and the y-intercept, so I just take out the m and the b. So for E, my slope is -3/4 and my b is -2. So I just plug in -3/4 x minus 2. And lastly for F, the slope they gave me is 2. My order pair is x1, y1. So let me put it into point slope. Y minus -2 is equal to 2 times x minus 5. Okay, and then for the last example, we're going to simplify the negative, distribute the 2, and then move it over, and then get -2, and y equals 2x minus 12. And that would be in slope-intercept form. So you do have the homework. It is section 3.5, and again, it's practicing with these three forms and writing equations of lines.